Hi everyone, I am Dr. Shigar Kanti, Associate Professor of Mathematics, Government First Grade College, KR from Bangalore. In this video, we study the session number 31 of third semester BSc Mathematics of Bangalore University, Bangalore City University and Bangalore North University. So in this session, we study the nature of the geometric series. The series summation x power of n is known as the geometric series. Okay, so that is here. If I write x power of n, summation x power of n equal to first term is equal to 1, then plus x square plus x cube plus up to x power of n plus and so on. Let me take the nth partial sum. The Sn is equal to 1 plus x square plus up to x to the power of n minus 1. This is the geometric series. Okay. Now sum of this series is given by, so here first term is equal to 1 and the common ratio is equal to x. Then sum of this is given by a into 1 minus r power of n divided by 1 minus r. R means x here. And a equal to 1. So therefore this sum Sn is equal to 1 minus x power of n divided by 1 minus x. This is for x is not equal to 1. Okay, because if x equal to 1, then this is not defined. Now what happens? If x equal to 1, then if I put x equal to 1 here, 1 plus 1 plus 1 plus 1 plus up to n times. That means here Sn equal to 1 plus 1 plus 1 plus up to n times means Sn is equal to n. Okay. And that tends to infinity as n tends to infinity. Sn tends to infinity as n tends to infinity because Sn is equal to n. And in this case, we say that the sequence Sn is divergent. Therefore, the corresponding series is also divergent. Okay. Next, we consider another case. That is, let x is greater than 1. If x is greater than 1, what happens to this? So that is if x is greater than 1, if we take the powers onto this one and if the power is high, then this becomes infinite. So that means this goes to infinity. So that is here xn goes to infinity means Sn tends to infinity as n tends to infinity. Therefore, we say that the sequence Sn is divergent. So that is if sequence Sn is divergent, then we say that the given series is also divergent. That is in this case the given series is divergent. If x is greater than 1, sigma x power of n is divergent. Next we consider another case that let x is equal to minus 1. If x equal to minus 1, then we have Sn equal to 1 minus x power of n divided by 1 minus x. So denominator no problem, 1 minus of minus 1, this becomes 1 plus 1 is equal to 2. So what about this x to the power of n? Now here if n is even number, then minus 1 to the power of n is 1. Okay. If this n is odd number, then minus 1 to the power of n is minus 1. So that is this x power of n is equal to plus 1 or minus 1. So that is Sn equal to 1 plus or minus 1 divided by 2. Now if this is plus, what I am getting 1 plus 1, 2 by 2, this is equal to 1. Suppose this is minus, then I am getting 1 minus 1 is 0, 0 by 2 is equal to 0. So that is, I am getting Sn is equal to 1 or 0. This is depending on n. That is, n is either even or odd. So if I take limit on this Sn, so that is if I take limit on to Sn, then I am getting Sn tends to 1 or 0. That means the sequence Sn is oscillatory, oscillates finitely. Therefore, the given series also oscillates finitely. So if x equal to minus 1, the given series is oscillates finitely. Next, we consider another case. If x is less than minus 1, x is less than minus 1 means this value numerical, this value is greater than 1 here. Less than minus 1 means it may be minus 2, minus 3, minus 4, minus 5 like this. Okay. If x is less than minus 1, what happens to x to the power of n? This goes to plus or minus infinity. So this may be minus 1, minus 2, minus 3, minus 4, minus 5, like this. Okay, that means this goes to infinity. This goes to infinity as that power is bigger. And this what this does, my negative sign gives either plus 1 or minus 1. So that means limit of x power of n is equal to plus or minus infinity if x is less than minus 1. Then we say that if x power of n is equal to plus or minus infinity, then what about Sn? Sn is also plus or minus infinity. That is Sn tends to plus or minus infinity as n tends to infinity. So that means the given this sequence Sn is oscillates infinitely. Therefore, the given series also oscillates infinitely. So x is less than minus 1. The given series oscillates infinitely. Now let me consider the next case. Let x equal to 0. If x equal to 0, what happens? Each term of the series is equal to 0. Therefore, sum of the first 10 terms is equal to 0. That means Sn is equal to 0. If Sn is equal to 0, then limit of Sn is also equal to 0. Therefore, the sequence Sn is convergent, and therefore the given series is also convergent. That is, if x equal to 0, the given series is convergent. Next, I will consider the case x lies between minus 1 and plus 1. X is less than 1 and x is greater than minus 1. I am considering here x is not equal to 0 because already I have considered this case x is equal to 0. Now x lies between minus 1 and plus 1. Then we say that x power of n, this tends to 0 as n tends to infinity. So that is here less than 1. As if we take the higher power onto this one, this is go on decreasing. Okay, finally it goes to 0. That is here xn tends to 0 as n tends to infinity. Therefore, what about this Sn? Here x power of n tends to 0. X power of n tends to 0 means this tends to 0. So that is, this term goes to 0. Then what remains here? 1 by 1 minus x remains. That is, limit of Sn is equal to 1 by 1 minus x. And x is finite quantity, fixed quantity. Therefore, this is a finite value. That means here the sequence Sn is convergent, and therefore the corresponding series is also convergent. Now, considering all these cases, then we say that the given series is convergent if x lies between minus 1 and plus 1. That is, x is greater than minus 1 and less than plus 1. And it is divergent if x is equal to 1 and x is greater than 1. And this oscillates finitely if x is equal to minus 1 and oscillates infinitely if x is less than minus 1. That is the nature of the series depending on the value of x. Okay. Thank you. We stop here.